Alright, I want to show you one of these Advent of Code challenges. The real fun of these is solving them yourself, so I'm going to move pretty quickly through this because this is just to give you a little bit of a flavor of what they look like and how you might approach solving them, and I don't want to spoil too much of the fun. We're going to look at the challenge from day 2, that was from December 2nd. I have already solved it myself, but we'll go through it again just to give you a flavor of what it is like. The story here is we're on a submarine looking for the keys to Santa's sleigh. And to help navigate the submarine, we have to write a program that uses data that comes from our sensors. The data looks like this. It's going to be a command followed by a number. The commands are either forward, down, or up, and the numbers are just regular integers. And then the instructions for how to interpret the commands are: forward moves the submarine forward by a certain amount, by the amount of the number. Down increases the depth, so we're underwater, so down means increase the depth, and up means decrease the depth. So we have to write a program that follows these instructions from our data, tracks the position and depth, and at the end we're going to multiply the depth times the horizontal position, and that's going to be our answer to this puzzle. In Advent of Code, every person who's playing gets different data, so it's not the same answer for everyone. So our data is here. You see it's a much longer list than in the example. I'm going to take this and select it all and copy it, and I'm going to be working in the environment provided by CodeHS. I needed a Python interpreter that we could use, and so this is the one that I am using. I'm going to create a new file to hold our data. So new file, I'm just going to call it data.txt, and then I'm going to paste the data into this file. Then my program that we're going to write in just a second can access this data. So Python is a good language to solve these challenges with because it has lots of functions for easily manipulating data. So let's go ahead and open a file with our data. So I'm going to say data equals, because I need a variable to store it in, open, and then data.txt. So again, that just opens the file and stores it to the variable data. And then one really nice thing about Python is it makes it easy to loop through a text file and look at each line in turn. All you have to do is say for line, or whatever variable name you want to use, in data. So this is going to loop through each line in the data file represented by the variable data and assign that line to the variable line. Okay. Now remember, our data looks like this. It's pairs of words and numbers. We want to separate out each of those parts so we can manipulate them and use them in our program. Python is good for this too because it gives us an easy way to split up a line of text. So I'm going to say command, comma, value. So command is going to be the variable that represents the word of the command, and value is going to represent the number, equals line dot split. In Python, strings, and right now line represents a string variable, that's just a piece of text, have functions attached to them that can do useful things, and this one will split up the text into parts wherever there's a space. And since there's a space between the command and the number, we get two separate parts, and Python separates them out into these two variables. Now, before we continue, I just realized I need to do something before I start this loop. I need to create some variables to hold the values we're tracking. Remember, we're tracking the horizontal position of the submarine, which is 0, which starts at 0, and the depth, which starts at 0. Okay. And then within the loop, based on our commands and our values, those are going to change. Alright, so right now we've got the command and a value. let's do different things based on the command to change our variable. So if command equals forward, so remember it said if the command was forward, increase the horizontal position. So we'll say position equals position plus value. So we're going to add whatever the number value for this command is to the old position to get the new position. Elif, so if it's not equal to forward, maybe it's equal to something else. So elif command equals down. Same basic thing, except this time it's the depth that increases. So depth equals depth plus value. And then elif command equals up. This time for an up command, the depth decreases, so that's depth equals depth minus value. So this loop will run for each line in the data, and depending on what the command is, it will change either the position or the depth variable. And then after it's done, so to be outside the loop, we have to unindent. So the things that are indented under 4 are the things that get repeated inside the loop. We don't want this last command to repeat. We want it to just run once. We're going to print. We'll say answer. And remember, the answer they wanted was the position times the depth. So we'll say position times depth. And that should be ready to run. Let's run it. And oops, we have a bug here. It says unsupported values for plus, int, so integer, and string. I guess that's right here. It says on line 7. I know why. Because this data came from a text file, it's interpreting the value as the string that looked like a number, but not actually treating it as a number. To fix that, we can add another line here that changes the value. We say value equals int value. So that uses the int function to take a string that looked like a number and turn it into an actual number. So now it should work. Let's try it again. All right, so we got an answer of, let's see, what's that? 1,762,050, which in fact is the answer that I got before and is the correct answer. All right, there is a part 2 to this, but we're not going to do it together. I will challenge you to try and solve that on your own if you like. Thanks for listening.